Alright, welcome back to the Green Ninja Climate Science video series. In this video we're going to be talking about how difficult will it be to limit future climate change. So when I say limit future climate change, I'm talking about limiting the amount of greenhouse gases that end up in the atmosphere so that hopefully we can avoid some of the potential impacts that we talked about in the last video. So the first point I want to make is that greenhouse gases, carbon dioxide, methane, nitrous oxide, come from many different sources. So this is a flow chart that's kind of illustrating that. This is showing world greenhouse gas emissions broken up by their different sectors and by their different end uses or activities. And so what you can see is that these greenhouse gases that we're emitting do not come from one single sector. There's not really a dominant activity that humans are participating in that's causing the vast majority of greenhouse gas emissions. It's really distributed among many different activities. So just to use an example, I think a lot of people would guess that SUVs are a big contributor to global warming. And while it's true that SUVs are not very efficient and there's a lot better ways to get around if you're concerned about how much greenhouse gases you're putting in the atmosphere, it's still the case that transportation overall, which includes road transportation, air transportation, rail, shipping, all of that combined is still only 13.5% of greenhouse gas emissions in terms of the total amount of global warming that's contributed by that sector. So we look around, we see electricity and heat is a big one, industry, land use change, which is mostly due to deforestation, agriculture, waste management. All these things are contributing to global warming by producing greenhouse gases. And so in order to reduce emissions of greenhouse gases, we're going to need to tackle this problem in all sorts of different industries, and we can't just single out one industry and think that we've solved the problem. So the second point I want to make when talking about trying to reduce the amount of CO2 in the atmosphere is to make clear the distinction between emissions and concentrations of CO2. So I'm going to go back to the analogy of the bathtub that we talked about in the carbon cycle video, where we said that emissions of CO2 it's a rate. So that's the amount of CO2 per year that's going into the atmosphere. And so this is analogous to the bathtub faucet, where you have a certain number of gallons per second going into the bathtub. Then the concentration of CO2 is basically like the amount of CO2 in the atmosphere. And so that's analogous to the water level, how high the water is in the bathtub. So I just want to take a look at some graphs here and see if we can get a better understanding of the relationship between emissions and concentrations. So I think it is easier to think about it in terms of the bathtub. So let's just say that over time we're going to linearly increase the amount of water going into the bathtub, and the drain is plugged in this case. So what's going to happen to the water level as we linearly increase? It's like we're taking our hand and we're continuously increasing the amount of water going into the bathtub. Well, the water level is not going to increase linearly. It's going to increase exponentially, because at each given time period, more and more and more water is continuously flowing into that bathtub. So you get essentially the integral of the top curve in the bottom curve, and you get an exponential increase in water level. So if we linearly increase CO2 emissions, we get an exponential increase in CO2 concentrations. So what if we were to level off CO2 emissions? So we're no longer raising CO2 emissions. So this would be like taking your hand off the faucet, and now there's just a constant rate of water flowing into your bathtub. Well, over time, what that means is that the water level is going to increase still. So the water level increases linearly if your rate flowing in is constant. So it may sound really good to level off CO2 emissions so that they're no longer rising, but that does not mean that the concentration in the atmosphere will level off. In fact, if you level off CO2 emissions, the concentration will continue to go up. So what if we start to reduce emissions? So let's say now that we are starting to reduce the amount of water going into into the bathtub by closing the faucet over time, what's going to happen to the water level? Well, it doesn't come down, it just slowly levels off. So you get an increase at a decreasing rate until eventually you turn off the faucet completely, and then the water level just stays where it is. So this is very much like CO2 in the atmosphere, that in order to stabilize the amount of CO2 in the atmosphere, we have to reduce emissions by a lot. Not actually down to zero in this case, because they're in the real climate system, it's like the drain is open a little bit. So there are natural sinks of CO2, but we do need to reduce emissions by quite a bit to stabilize the concentration. So to put more concrete numbers on this, this is a scenario. We are looking at three graphs here where we have emissions of CO2 versus concentrations of CO2 versus temperature change. And we have two scenarios. We have constant CO2 emissions at the levels that they were at in the year 2000. That's this red line. And you can see that the red line exists in all three graphs. And then also the emissions that would have to occur over time in order to stabilize CO2 concentrations at 550 parts per million. So that's this blue curve where we have the concentration of CO2 in the atmosphere going up and eventually stabilizing at 550 parts per million. So the first thing I think to notice is that CO2 concentrations and temperature basically look about the same. As CO2 goes up with the red line, temperature goes up with the red line. As CO2 levels off with the blue line, temperature levels off with the blue line. But look over here what is actually going on with emissions. So in order to level off emissions at 550 parts per million, the situation is we have to reduce, or in order to level off concentrations at 550 parts per million, we have to reduce emissions down to about 2 gigatons of carbon per year. So what that means is if we were at 10 gigatons of carbon per year of emissions in, say, the year 2010, we essentially need to reduce these emissions by 80% just to level off CO2 concentrations at 550 parts per million, and that's going to level off temperature. Now, if we keep CO2 emissions at constant levels, we don't increase them at all, but we keep them at the same level that they were at in 2000, that just means that the CO2 is going to continue to accumulate in the atmosphere, and the temperature is going to continue to rise. So in order to get stabilization of temperature, we need to reduce emissions by as much as about 80%, which really highlights the challenge that is limiting climate change in the future. And so it's important to point out that we are not very close to reducing emissions. Currently, emissions are still increasing and increasing. So the next step is to hopefully level off emissions and then reduce emissions down to 80, by 80% of what they basically are currently. So this is a big challenge, and it will take a big effort from a lot of people. So how difficult will it be? I guess that's up to the policymakers and the people that are going to be tackling this problem. But it's important to know that it's not something that we can just look at one sector and solve the problem that way. It's gonna take efforts across many sectors, and it's gonna take a big reduction in emissions to get a leveling off in concentrations and a leveling off in temperature.